So again, welcome to the uh, IR spectroscopy part 5. After completing successfully all the theory as well as the instrumentation of IR spectroscopy, now I'm going to deal with some question answer session and also give you some assignments. So friends, let's start. We're going to see certain MCQ questions which will be very useful, some true or false, some match the following, and I'm going to ask you some assignments to solve for short answer questions of 5 marks and long answer questions of 10 marks. Let us begin with the MCQs. We have to use only one correct alternative. So first is, let's begin. IR spectroscopy is based on electronic transitions, nuclear spin transitions, molecular vibrations, molecular fragmentations. So naturally, IR is a vibrational spectra, so the answer is 3. So 3 is the answer. IR has a smaller wavelength than UV visible, X-ray, gamma ray, microwave. Now if you visualize the electromagnetic spectrum, you have to find out what lies on the right hand side on the electromagnetic spectrum as compared to IR. And I think UV, X-ray, gamma, they all come on the left side. It's only microwave radiation which comes extreme right. So the answer should be 4. Infrared region, which is routinely used to identify functional groups of organic compound samples, is 12,500 to 4,000 centimeter inverse, 4,000 to 600 centimeter inverse, 4,000 to 200 centimeter inverse, and 200 to 10 centimeter inverse. We have to recapitulate. There are 3 infrared regions: near, mid, and far, and we are actually dealing with the mid. And mid, these two are mid, but practically we are dealing with 4,000 to 600. So the answer should be 2. Yes. Frequency of bond vibration as per Hooke's law is not dependent on force constant of the bond strength, atomic masses, resonance energy. If you visualize the equation of the Hooke's law, you have force constant in the numerator, and more or less bond strength also depends on the force constant, and at the denominator you have the atomic masses, okay, the reduced atomic mass, that is the product divided by the total divided by the product of the masses, and therefore it's resonance energy which does not it doesn't depend on resonance energy. So the answer is 4. Number of fundamental bands in a linear molecule are 39.6, 39.5, 39.4, 39.3. We have only 2 types of molecules, linear and non-linear, and for linear molecules it is 39 minus 5, and therefore this should be the answer. In the following sampling technique, neat sample is used. So which technique? Pellet, mold, solution, ATR. Neat means without mixing anything in the sample as it is. So it is ATR, attenuated total reflectance. Other places we are either using Nujol or paraffin or KBR, or we are using chloroform or carbon tetrachloride or something like that. Amides shall exhibit carbonyl stretching vibration around roughly 1650 centimeter inverse, 1720, 1750, 1800. These are all carbonyl, and if you comparatively see all carbonyl groups, the amides are the lowest, and the lowest is 1650. Answer should be 1. Primary amine shall exhibit stretching vibrations around Basic thing about primary vibrations, primary amine vibrations, they generally give, you can say, a doublet. Okay, and so uh, they should give a doublet, and the amine region is definitely 3200 to 3400. Okay, these are the other regions, so the answer should be one. Which of the following shall have highest carbon stretching frequency? Ketones, aldehydes, esters, or hydrides? Naturally, it has to be the hydrides. Which of the following exhibit highest carbonyl frequency? These are the cyclic ketones, so cyclopropanol, cyclobutanol, cyclopentanol, cyclohexanol, and we have to recollect that the ring size and ring strain enhances the smaller the ring size and more the ring strain, the frequency goes to the higher centimeter inverse, so it is cyclopropanol. Which radiation source is not used for the mid IR range? That is the range which we are talking about or we are dealing about. So nurse glower is very much there, clover is there, uh, and then it's mercury arc, which is not, because incandescent filament is also there. Which shall have the highest stretching frequency? So again, we recapitulate our uh, video, the very first video, where we express the basics of bonding vibrations. We could see that the CH vibrations is so much in 1 second. It goes to even billions and trillions. So it is CH. Which is not true. Fourier transform converts interferogram to spectrum. Fourier transform converts time domain to frequency domain. Fourier transform converts frequency domain to time domain. Fourier transform IR entire frequency of IR spanned simultaneously. So the answer is 3, of course, because this is not there. This is interferogram. First it takes and then it converts into spectrum, and this is based on time. So time domains is converted to our normal spectrum of IR, that is frequency domain. It also, the difference between dispersive and Fourier is it takes the entire frequency of the IR is spanned simultaneously. So only 3 is not true. Which has the highest vibrational frequency? CN stretch, CC triple bond stretch, CC double bond stretch, CC stretch. So CN stretch, C triple bond stretch. This is a cyno or nitriles. That is the highest. And that comes around 2200 plus. Okay. Benzaldehyde will not show one of the following vibrational frequency. Benzaldehyde will show carbonyl. Benzaldehyde, because it is benzene ring, it will show aromatic CH. It will also have the benzaldehyde aldehyde CH. However, 2200 will not be seen. Which one of the following is the wave number of near infrared spectrometer? So we start first from the higher side. We go to the lower side of the frequency. I think the highest is 12,500 to 4,000 centimeter inverse, and so that is the answer. Which of the following is not a composition of nurse glower or nurse filament? Nurse glower or nurse filament, they deal with the oxides of rare earth metals, and barium is not a rare earth metal, so it is naturally the second is the answer. What is the composition of a Glober rod that is used as a source in mid IR spectroscopy? and that is silicon carbide and silver chloride and silicon dioxide and silver carbide, and the answer is of course silicon carbide. Okay. The detector bolometer is also known as resistance temperature detector, RTD, thermistor, thermocouple, and Gole cell. And the answer is very simple. It is also called as thermistor. Which of the following is not used as bioelectric material in bioelectric transducers in infrared spectroscopy? Triglycine sulfate, deuterated triglycine sulfate, some polymers, tetraglycine sulfate, and naturally it is tetraglycine sulfate which is not used. In a solid sample treatment, the finely solid sample is mixed with mineral oil to make a thick paste which is then sprayed between the IR transmitting windows. What is the name of this solid sample treatment technique? Whether it is called the pressed pellet technique, whether it is called as the mull technique, whether it is called as the solid films technique, or whether it is called as the solutions to solids of solids technique. So it is called as the mull technique, visual mull technique. Which value is correct? Reduced mass of HF, and one atomic mass unit is given as 1.66 into 10 raised to minus 27. So you have to first find the reduced mass, that is the multiplication of the atomic masses of HF, and then divide their total, and then that you multiply with this, and if you work this out, the first will come to 1.59 2 raised to minus 27. That is in simple words. You have to uh, this you have to total them first and divide by their multiplication. That is 20 upon 19. 20 divided by 19, that comes 1.66, and then that you have to work out. The force constants of CO and CS are 1902 and 849 uh, 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 nanometers inverse respectively. Which statement is incorrect? The wave number associated with the stretching of CO is higher than of CS. Stretching of bond in CO requires less energy than stretching of the bond in CS. The trend in bond energies for CO and CS follows the trend in force constant. Less energy is required to dissociate CS than CO. And naturally, I think the second answer is right. What statement is incorrect about CO2? Our spectrum of CO2 shows four absorptions. It is a linear molecule. Uh, it has two degenerate bending modes of vibration, and it has two stretching modes of vibrations. Now, there is a catch in this. Uh, the uh, the answer is definitely one, because though this has two and two, these don't sum up because these are the vibrations, but they are not seen as bands due to in certain cases not having the dipole moments, or the some dipole moments being cancelled out. And therefore, actually, standard spectrum of CO2 shows basically only two distinct vibrations and not four vibrations. Which of the following absorption peak or peaks would be most useful for identifying the compound diethylamine? So diethylamine is a secondary amine. So sharp peak is out of question, and that too at 1750 centimeter inverse, and two medium peaks at 3300. Okay, these are the IR region. very broad break from 2500 to 3500, and medium stretch from 3500 to 3300 centimeter inverse, and the answer is 4. Yes, you will never get a doublet because it is secondary amine. There are no free amino groups. Which of the following statements about IR spectroscopy would indicate the successful completion of the reaction of pentanol with Tollens reagent? So basically you have to understand, after reaction with Tollens reagent, what will happen to pentanol, and that product should give a peak where, and that is very the aldehyde is going to be oxidized to an acid, so you have to search for the acid peak, and naturally the answer will be definitely 1, broad peak. What is the order of the following carbonyl compounds in decreasing wavelength number? Wave number: butanol chloride, ethanol butanate, pentanol, propionic acid. So decreasing order, so which will be the highest and which will be the lowest, and let us see what are the options. These are the 4 options, and if you see here, and definitely first try to find out which is going to be the lowest and which is going to be the highest. Okay, and therefore the answer is 2. That is, pentanol being the aldehyde is going to be the lowest, and butanol chloride will be the highest, propionic acid will come second, and the ester will come third. Now we will deal with certain graphs, and this question is based on the interpretation of the graph. Based on the absorption spectrum, what is likely the name of the compound below? Choose one answer from the 4 options, whether it is diethylamine, whether it is aniline, whether it is pentanol, whether it is butanoic acid. One thing is very sure, that it is not pentanol, and also it is not butanoic acid, it is diethylamine. It is very much diethylamine, and yeah, this is not a very characteristic about aryl CH vibrations, and therefore this is diethylamine, more characteristic about the methyl groups. In the absorption spectrum provided below, assuming that the 2 plots represent the same compound, which of the following statements must accurately describe the graph? The assumption is incorrect, and they are in fact 2 different compounds. You have to concentrate on the fingerprint region, and you have to also identify that there are certain what is say, in the functional group region, there may be certain things which are coming due to the solvents, and if I see, I find they are mostly matching here, almost peak to peak. So only here a broad peak has come, and this may be due to 2 phases, solid and liquid. Due to the liquid, this broad peak has come. So I think it is, answer is sorry, that it is due to water, and therefore I think the sharp peaks are of course in chloroform. This is water, so the answer is 2. You have to identify what is this graph now. What does it tell? And these are the options. Identify. Benzyl alcohol, 2,4,6 cycloheptatrienone, acetophenone, benzaldehyde, phenylacetic acid. So one has to really think what it is, and The answer is it is benzaldehyde. This peak is very much of the aldehyde, and this is also talking about both the aryl and alkyl stretching vibrations. Same thing, what is this? These are the options: 2,4,5 trimethylbenzaldehyde, parallyl anisole, parallyl 4-methylphenol, and 1-phenyl 2-butanone. Now again there is a carbonyl. This carbonyl is well above 1700, so but not 1750, so it has to be an aldehyde or ketone. These are ruled out. These are definitely ruled out, and it goes more in the favor of uh, yes, 1-phenyl 2-butanone. Again, what is this? Identify the compound from the IR below. It is cyclopropanone, propinol, acrylaldehyde, propanoic acid, and we search, and we don't get any carbonyl, so we rule this out, and even we may rule this out. Let us see what it is. Okay, so it is propinol. Let us see. Methyl benzoate. We have got something around 1685, and we have all four are having some carbonyl group. Fine. And what peak we are getting is at 1685, and the lowest will be, of course, it has to be anisaldehyde or hydroxyacetophenone, but I don't see much broad things here, so it is anisaldehyde. Okay. Identify the compound from the IR below. Benzyl formate, orthohydroxyacetophenone, methoxytropone, paratolic acid, orthoanisaldehyde, and once again I go for what is say the more diagnostic group, 1600, 1700. This is coming slightly less than 1700, and here this is an ester, this is ketone, this is ketone acid. I rule these two out. Mostly I support this. No, it's paratolic acid. Okay, it's paratolic acid. Because of this, true or false remarks. Energy of the radiation is directly proportional to the wavelength of the radiation. Um, True or false? Definitely it is false. Resonance conjugation energy increases the stretching of carbonyl group. True or false? Definitely it is false. Rather reduces. The FTIR spectrophotometer collects all wavelengths of incident IR simultaneously. True or false? True. Collects. We saw that. The zero part difference is obtained if both mirrors are in the same distance. Absolutely true. Optical part difference of half the multiple wavelengths lead to destructive interference. True. FTIR spectrophotometer requires longer time than dispersive spectrophotometer to record a spectrum of sample. True, false. Actually, it is very fast. Micro radiation energy is stronger than higher energy as it can hit certain samples. No, it comes on the extreme right, so its frequency is very less. Its um, frequency is very less, and therefore it is again false. An FTIR spectrophotometer, there is standard as well as sample use simultaneously. We don't use the standard at all. KBR palette is the best way of sampling solids for qualitative wire analysis. Yes, by far still it is, though we have ATR, but KBR palette is the best. Fingerprint region is equally useful to establish the identity of an unknown organic compound. Yes, very true. You have to match the following, and you have carbonyl stretching, and you have CH stretching, you have CH aliphatic aromatic, you have CN stretching, you have NH stretching. It's very simple, and uh, let us see how we can proceed. So carbonyl we can say will come from this, and CH stretch aromatic we can say will be this. CH stretch aliphatic will be this, and CN stretching will be this, and NH stretch will be this, and let us see what are the answers. So 51 is C, 52 is 52 is D, 53 is E, 54 is B, and 55 is A. Fine. Now let us see. C triple bond CH vibration, C triple bond N vibration, CC stretching vibration, CN stretching vibration, CH stretching vibration. Let us see what is the answer. And yes, so we have this CC triple stretching vibration is of course this, and CN is still little bit higher, so it is this. CC is 1680, and what you can say is C double bond N is the lowest, this, and the CS is still lowest. Yeah, so these are the answers. And now you have to just see this, copy down these short answer questions of 5 marks. What is the range of IR vibrations? You have to write. Why are the IR? You have to describe these ranges of IR vibrations and discuss them. Why IR is called as vibrational spectroscopy. You have to explain why it is called. Different types of vibrations you have to express. Why some of the fundamental vibrations are IR active and others are not. You have to discuss the dipole moment concept. What are fundamental vibrations in overtones? You have to discuss, including the degree of freedoms and Fermi resonance and other things. Explain Fermi resonance and combination bands. How can IR be used as a distinguish type of um, hydrogen bonding, explain various regions of importance in typical IR spectrum, explain various IR sampling techniques, why wave numbers are used and not millimicrons to express, why we are going for a centimeter inverse instead of millimicrons. And, we have to explain that. Enlist five various applications of IR spectroscopy. Describe main steps involved in the interpretation of an IR spectrum. Enlist ascending order the frequency of CO stretch each of the following: aldehyde, ketones, esters, anhydrides, amides, and acid chlorides. How will you distinguish between alcohols and carboxylic acids? How will you distinguish between methyl and alkyne? Comment on the CH stretching vibrations of alkanes, alkenes, and alkynes as well as benzene with proper explanation. How IR is useful in distinguishing amongst monosubstituted as well as ortho-disubstituted, meta-disubstituted, para-disubstituted benzenes. Explain why glass or water are not used as material of optics or samples in an IR spectrophotometer, and what material is used then. And there are certain long answer questions. Explain the principle and working of FTIR spectrophotometer, its advantage over conventional dispersive spectrophotometer. These are all 10 question, 10 marks questions. So you have to go in details with diagrams. Discuss the basic principle and theory of IR spectroscopy in details. Discuss the factors affecting higher vibrational frequencies. Discuss in detail the interpretation of higher spectra. Discuss in detail the higher functional group analysis. Discuss the applications of higher spectroscopy. Discuss the instrumentation of dispersive higher spectrophotometers. And short notes, any two, but you can try to do all the five. So it will be good. We have discussed the IR spectrum, characteristic group frequencies, the fingerprint region and its application, sample handling for IR spectral determination, and detectors for IR spectrophotometers. So, thank you very much, and I wish you all.